Hello and welcome to this video, topic 1.1, Introduction to the Particular Nature of Matter and the Chemical Change. So this topic is an introduction chapter to the topic 1, that is geometry, which is the calculations in chemistry. We're going to start by looking at the essential idea and the syllabus. The essential idea for this topic is that physical and chemical properties depends on the ways in which the different atoms are combined. There are mainly three different things we are going to focus on this time. The first is the change of the states. We're going to look at the notation for the different states and also the name when we change the state to different, like melting, freezing, boiling, condensation, and so on. We're going to look at how we can balance chemical equations and the method for that, and we're also going to have a quick look at the mixtures, and we're going to distinguish between what we call a homogeneous from a heterogeneous mixture. So these are the three different things that this topic is about, and we are going to start with the states and the change of states. I'm going to now draw you a picture. We can draw a particle like water if it is in gaseous state. If it is in gaseous state, it will move kind of rapidly. So we can see that we have a big distance between the water molecules. If I will draw it like if it's in liquid state, it's more like we have some distance, like this. And so they're floating around, and if we have it in solid state, it's more building this crystal, so it's more like this. So there are three different states we can expect seawater in. Gas is one thing. Notation is just G for gas. We have a liquid that is notated with a small l, and we have solid state, that is S. If we see that we will boil the water, it goes from liquid to gaseous state, and we call that vaporization in a nicer word. Vaporization. If we let out, we take out from the freezer ice and make it melt, it becomes liquid. So the process where the solid goes from solid to liquid is called melting. Then if we put in the water to the freeze, it will freeze, of course. So freezing is the process of where we can see it goes from liquid to solid. And then we can see that if we have water, like steam, and maybe we put a lid on it, we can see that it will form liquid, and we call the process where it goes from gas to liquid as condensing, or condensation. There are also two processes where we can see it goes directly from gas to solid or solid to gas. If the solid goes directly from solid to the gaseous state, the process is called sublimation. We see it here, sublimation. And if it goes directly from gas to solid, we call the process deposition. So this is all the different change of states that we can see. Once again, the state symbol is really important to know. We can have, for example, if we have oxygen gas, that is O2 in gaseous state, you will write it like this. If we have water, liquid, that's H2O and the liquid state. If we have sodium chloride, the salt, when it's in solid state, we will have that as S like this. That is sodium chloride. And also, if we put some of the salts into water, that will become an aqueous state. For example, if we take copper sulfate and we notate it with AQ, that means that the salt has been dissolved in water. So that's an AQ. The next thing I'm going to talk about is how we balance chemical reactions. My tip for you is to do this in 3 steps. So here is the method. The first thing is that sometimes it's not written with chemical symbols, it's written with the names, like the letters, and you need to rewrite it with the chemical symbols. So the first tip is to just look at the chemical symbols for the reactant and products. When you have done that, you need to set up the chemical equation, and you need to balance, and you always balance with the coefficient, that is the number before. Don't stop until you have equal amounts of atoms on the both sides of the arrow. And then in the third step you will just state the chemical reaction or equation with the correct states. So these are the 3 steps balancing. I will now have some different examples of that. We can start with potassium in solid state that reacts with water. That would dissolve the and create potassium hydroxide. And we also have hydrogen gas here. So the step number 1 was to state the chemical symbols. That is already done. So we can go to step number 2. Now we need to count how many atoms we have on the both sides. We have 1 potassium here and 1 here, so that is okay. We have 2 hydrogen here, but we have 3 on this side, 1 plus 2 here. So that is not balanced, and we have 1 of this and 1 of this. So what we can do is that we work with equal amounts, because we need to do that here. So my tip for you is to write a 2 in front of potassium hydroxide. And you can see that in that case we need a 2 also here to balance it. Now we have 2 potassium here, 2 here. We have 2 hydrogen here, we have 2 plus 2, we have 4 here, so we need to balance it with a 2 here also. Once again, we shake it again. 2 potassium, 4 hydrogen, 2 plus 2, 4 hydrogen, and we have 2 oxygen and 2 oxygen. So now we have the equal amounts of atoms of the both sides of the arrow. The third step is that you write it more clearly, and also don't forget the state symbol in the end. When you're doing the balancing, you don't need to write down the state symbol because this is during the work, so it just takes a lot of time to rewrite the states once every time. You can, in the middle process here, you don't need to do that. Okay, so 2 potassium in solid state is reacting with 2 water in liquid state. That will form 2 potassium hydroxide in aqueous state plus hydrogen gas. This is the balanced one. Okay, we take one more. In this case we have the iron oxide. It will react with carbon to form carbon monoxide and pure iron. So the first step is also ready here. We have already notated the chemical symbols. Now we're going to look at the balance. We have 2 iron here, but only 1 here. So the first thing I'm going to do is actually to balance the iron here. And I will do that by put a 2 in front of the iron here. Okay, we continue here. We have 3 of this one here, but only 1 here, so maybe it's good to take a 3 here also. Okay, we are looking again. 2 iron, 2 iron, 3 oxygen, 3 oxygen, 1 carbon, 3 carbon. Okay, we need to put a 3 here also. Okay, double check once more time. 2 iron, 2 iron, 3 oxygen, 3 oxygen, free carbon, and free carbon. Well, now we're done. So now we can write the third step with the state symbol. Yes, so now we see iron oxide will react with carbon in solid state, create carbon monoxide and iron. That is when we have given chemical symbols. Sometimes it can be that it's written with words, and in that case we need to, in the first step, actually write down the chemical symbols. So this task is this one here. In this case we have a synthesis. It means we put them together. So the synthesis of ammonia, that means that it's a product, is from the nitrogen gas and the hydrogen gas. Okay, so we go here. Nitrogen gas reacts with hydrogen gas. N2 gas plus hydrogen gas will create ammonia, and that is NH3. Okay. Now we can just see in step number 2, 2 nitrogen here, only 1 here. So probably we need to put a 2 in front of the ammonia here. And now we continue, 2 nitrogen, 2 nitrogen, 2 hydrogen, 6 hydrogen. Well, we put a 3 here. Double check again. N2, N2, 6H, 6H. Okay, it's okay. Now we can just write it with the state symbol. Nitrogen react with hydrogen gas to create ammonia. The last thing I'm going to talk about is mixtures, and the thing you need to have with you here is actually mostly the difference between a homogeneous and heterogeneous mixture. One thing you need to know before this is that the mixture, what is it? Well, it's not a compound that they have not chemically reacted together. They are more like in a mix together. It's like mixing salt and sand. They will not react and create another species or another compound. They're just a mixing of salt and sand together. And you can separate them from each other without making any reactions. So that is a mixture. So a mixture contains more than one element and or compound that are not chemically bonded together, so they can retain their individual properties. What you need to know here is the difference between what is a homogeneous and heterogeneous mixture. And I will actually give you an example here. If we mix, for example, salt and iron pieces, imagine that you have salt and iron pieces together now, and you mix them together. Well, you can separate them by maybe taking a magnet, and you can take out the iron pieces. In this case, it's a heterogeneous mixture, because you can easily separate them from each other by just like picking it up, in this case take the magnet. A homogeneous mixture is, for example, if you put salt in water. It's not that the salt is reacting with the water and create another compound, but it will dissolve. So you cannot easily just pick out the salt particles from the water because it's dissolved. So in this case it's a homogeneous mixture. So a homogeneous mixture is when you cannot pick out the different components to see them, while in the heterogeneous you can actually kind of easily separate them from each other. This was the introduction to chapter 1, stoichiometry, the intro to matter. Thank you for watching.